Hi, my name is Farhana and welcome to the session on trigonometry rules. Have you ever wondered how is it that pilots know in which direction to fly it when there is a strong wind blowing? So, that's going to be one of the questions we're going to answer at the end of this session. We're going to look at how flight engineers will use trigonometry to draw a triangle and use trigonometry and some of the rules we do today to solve that triangle and find the angle at which the plane needs to fly in order to reach its destination. Okay. So far, all the trigonometry you've done thus far has been dealing with right angle triangles. So in grade 10, you've covered all of these sections. However, today, we're going to begin solving non-right angle triangles. And specifically, we're going to be looking at three rules: the sine rule, the cosine rule, and the area rule. A little bit later, we'll be doing some proofs and applications for all three rules. The first two rules will help us to find the lengths of sides as well as unknown angles in non-right angle triangles. The area rule will be used to find the area in triangles when we don't have enough information to use our regular half base times height formula. Okay, so now we'll begin with today's lesson where we will be dealing with the sine rule. And remember, the sine rule is one of those rules that's going to help us to find the lengths of sides as well as the size of the angles in non-right angle triangles. Before we start, we need to get through some keywords. The first word we're going to deal with is oblique. An oblique triangle is a triangle that has no right angled, that doesn't have any right angles in it. So, this triangle ABC, you can clearly see that none of these angles are right angled. So, the sine rule again, we're going to be using it to find some angle that's unknown or the length of some side. So either we'll be finding an angle here, angle A, or we could be finding, for example, the length of AC. Before we begin, we need to revise some of the conventions of labeling a triangle. So let's go back to the board. If you recall, when we label triangles, each vertice, for example, in this triangle, which we call triangle ABC, each vertice is labeled with a capital letter. And so this vertex is A, B, and C. And that also represents the angle. And the side directly across it, so the side directly across A, is labeled with a lowercase of the same letter. So across angle A, we have lowercase a, which means it's representing this side, BC. Okay, and when we have uppercase B, the side directly across it will be labeled with a lowercase letter b. And similarly for C and little c. So what is the sine rule? So the sine rule, let me just clean this up first. So what is the sine rule? The sine rule is a very simple rule to remember. It says sine A over A is equal to, sorry, let me just get this pen. Sine A over A is equal to sine B over B, which is equal to sine C over C. And we have another version of this, the reciprocal version. The reciprocal version, we basically flip that equation upside down and we begin with the lowercase letters on top. So lowercase a over sine A equals to B over sine B equals to C over sine C. So when we're trying to memorize the sine rule, it's really, really simple. We're always talking about sine A over A equals to sine B over B equals to sine C over C. But what happens if our triangle is not labeled with ABC? What then? Let's look at that. So if we have a triangle PQR, as we do here, the side opposite P is labeled little p, and we have labeled Q, little q across from the vertex Q, and similarly with R. So we just adjust the formula for the sine rule using P, Q, and R. So our formula will look like this. Sine P over P equals to sine Q over Q, which equals to sine R over R. And the reciprocal version, little p over sine P, and similarly Q over sine Q, and R over sine R. Okay, so when we're using the sine rule, we need to think about two very important things that we need. In order to use the sine rule, we need to be given one full pair of sides and one half pair. What does that mean? Let's look at our diagram again. If we were looking for side A, we would have to be given the angle across it, and this would be our half pair. And we would be needing to be given another full pair. And what do we mean by a full pair? We need to be given angle B as well as the side across it. So we've got a half pair here, and the red piece is our full pair, which means which version of the sine rule will be used? Again, because we've got sine A, we're looking for the side here. So because we're looking for the side little a, it means we're going to use the version where the sides are in the numerator. It just makes our calculations a bit easier. So we're looking for little a, which means that's the one we're going to start off with. So we're going to use a over sine A, that piece. And because the other pair we're given is this full pair we've given, which comes from this part of the equation, b over sine B. So if we're trying to solve this diagram and we want to solve for little a, we're going to use this piece of the sine rule. Let's try one more. Okay. In this diagram PQR, they want us to find R. So if they want us to find angle R, we must be given the half pair across it. We must be given side R. And the other pair that is given here is P and little p. So we need to find, this is the angle we need to find angle. So because we're looking for angles, it means we're going to use this version of the sine rule where the angles are in the numerator. Again, we're going to use this version, but we're going to start off with what's unknown. Because R is unknown, we're going to start off with that piece. So that's our unknown, and we know we have that piece here. And the other pair we're given is the P and the side P. So which formula will we start off with? We're going to start off with that one, and specifically, we're going to be starting off with sine R over R, and this is our half pair we're given, and that's our half pair we're given. And on this side is sine P over P, and that's our full pair we're given. Okay, I think that was a lot to take in. Let's take a short break and come back to see how we can apply the sine rule.